Hey everybody, it's Luke Parisi with a video on the engine I've been working on. This week I focused a lot on the collision and getting a lot more conditions fixed, as well as fleshing out a physics system and doing some prefab functionality. So it's not much to go through this week, but yeah, it's mainly just the collision stuff. So I'll show that off quickly and show you what I've been working on. So this tree here is fixed. The scale is a bit better. And what I've done with the models is when I update the scales, I update the collision box. And I've made it thinner, this one here, and I've made the jump a bit weaker. And also I've made it so you can't jump while you're in the air, so it's just like a usual jump. Not as high anymore, but yeah. I've also added a gravity system, which was existing with the player. I just added it to the models. And yeah, as you can see, these cubes have gravity affected. This one doesn't. Well, this one does, but it falls and then lands. These ones fall and bounce. So as you can see there, when they get on top of this platform, they bounce from the platform. But these ones underneath, they get stuck, and that's pretty much, I haven't done the collision from underneath these platforms yet. See, as I'm stuck as well, so same functionality. So yeah, what happens is pretty simple for the falling and bouncing. So falling has the exact same gravity as the player, and then so with all the collision, I've added model to model collision. So that's what's happening here. The model is falling until it hits another model. For this one, if it hits a floor or a platform, I think I have ramp as well. I actually think I have on any. But when it hits, it just reverses the velocity. And then, as you can see, so it hits, reverses velocity, goes back up in the air, exact same amount it was, and then gravity starts affecting it again and it falls. It's a pretty straightforward, and then all these have different bounce velocities. So that one is reversing it back to its normal velocity. So like that one, actually I don't think it's reverse, I think it's just a static. So this one is static 5 float back upward, and these are 0.1. So they just keep bouncing slowly, and then like 0.1, 0.2, 3, 4, 0.5, and so on. So as you can see, they bounce. And then, so I was mucking around with the rotated. So this wall slowly rotates because I was starting to work on the pushing X and Z on the X and Z axis as well, but I haven't done much with that yet. So what I've done here as well is, this is the start of a prefab. So all I have to do is call one line of code now and just add prefab. This one's, I've just named house, and this is just an example one. They're not going to look like this, obviously. And that generates all these objects in the correct position. You just call the prefab once and set one vector 3 position, which in this one's case was here. I believe it was either here or here, and from there it generates all the objects. So that, what I was thinking with that is, when I have procedural generation on the environments, I'll have a prefab of one house or a prefab of, a maze or something, and then the random generation will just generate a bunch of them and then randomly place them on the map. So that works a bit. And then as you see here, I'm gliding along the wall. Now I can't remember in the last video if I had that working, but what was happening initially was, as I glide across the walls when there's a collision on two, it would either go through this gap because this this wall here would think it's allowed to go forward on the z-axis because it's no longer colliding with that one, but it's colliding with the edge in there. So on this edge it's saying yes, the condition is met that it can glide on the z-axis. So what it was doing that, and then I fixed that to prevent all movement if it was colliding with one or the other wall. If it started going through the z-axis here, it would say, alright, if this or this is colliding, then we can't go through the z-axis. So what would happen is you'd go and then you'd stop on this wall, and then you'd go and stop on this wall as well. But yeah, so now it's fixed. Each wall, it's kind of not perfect, but it will work, but it kind of limits some. So this wall, if it has 0 rotation, it allows a glide on the x-axis. Same with this wall. So both of these walls are allowing an x-axis glide. So if both allow that, when you're colliding with multi, then it will allow that continuous x movement. If it's an xz, then it's just normal. So you get stuck there. And then it's the exact same in the inner corner, you get stuck in that corner, as it should, but on the outside corner it's kind of. So then let's say there was another wall here, then we'd have 2 walls with Z glide allowed, so you could just keep continuously moving this way. And I've added detection for if there's multi. I'll turn on, so if you saw from last video, there's no text here at the moment besides the current level, which I've renamed. So there's only this level, physics test and transition test. I'm just changing the debug mode to true, that's why it's black screen. I'll set this back. There we go. So at the moment I've just set it to a bool now, so there we can see everything again. So there you can see a few new text. Here there's multi-collide vector and colliding up the top here. If you look, when I've to colliding ground 32, colliding wall 1, colliding door stone. So I've added a few conditions. If on collide there's two wall objects or a wall and a door, then it does checks on them. So it's always pretty much colliding with the ground. If I do that, you can see it's flickering, whereas if I hit that, it's not. And that's because when you hit the wall, it sets your Y. So if you look cam pos Y here, 2.25 exactly, where here it's 2.2516. So it's not exactly, it's not exactly on. But that doesn't make too much of a difference besides seeing that colliding flicker. And here I had this cube as well fall and hits the ramp and stays. So that's just testing the collision with the ramps as well. So as well, I've broken up the ramps into 2 types. This type here is the ramp sticky. As you see, colliding ramp sticky. And at the moment you can't jump on it. Unless you're up the top here, which it does this bounce anyway. So that's one. And then if you see here, it does this. You pass through the platform. So there's still a few things that are not ideal, but yeah. But if you go through, if you're on the ramp as well, you can pass through, which it's kind of weird interaction. And I went through this for a little while, trying to figure out how I want to handle it. And I actually fixed it, but it wouldn't do the block here. It wouldn't prevent you from keep moving through the ramp on this side. So I've kind of gone to leave it in, and I'm just never going to have a platform pass through a ramp, which it shouldn't anyway. So yeah, they're the ramp stickies. The sticky means that you stick to it, where ramp slippery, you slide down. I've actually got them as the same ground 32 ramp sticky. See that? It says ramp sticky, but they're both, the collision type is on this one ramp sticky, the collision type on this one is ramp slippery. So same with this is a ramp slippery. So I spent a bit of time getting these right as well. So the one axis rotation is fairly straightforward to calculate the, so there you can see it's directly straight line down, and what that's doing is on your X position, it gets your X and Z, and then it calculates based on this ramp where your height should be, and then it applies a downward movement just like gravity, but that's constant. It's not that gravity acceleration. So you stay at a constant velocity the entire time you're sliding down the ramp. So that one's alright. And then for this one, it does it for both X and Z, which was a bit hard to figure out, but yeah, that's all done. So if I was at the top of this, which I can't jump at the moment, if I was at the top of that, I would fall in line with this plane here. So it'd fall from that corner directly down to this corner. So I've added this because let's say there's mountains and that, I can make ramp slippery or whatever based on the mountains. So, like Skyrim, you can kind of jump the mountains, but yeah, with this, you won't be able to. So it just pushes you, and then when you hit it, you kind of do this bouncing because it's still pushing you away. It's kind of annoying, but yeah. This physics system keeps getting changed and changed anyway, so I've changed these doors a bit. So that's a lot of the collision. Yeah, as you can see there, you fall. There's gravity. I'll check the patch nodes. So yeah, that was the other thing I didn't really talk about, but when you go up and down the ramp, you don't do that bouncing downward anymore. You just glide on the ramp, and then so you stay there. And that was the other thing I fixed as well, mainly because it was only one little thing that needed to be changed, and that was the starting draw. But when you were standing next to a wall or whatever, you could see through it, especially on high FOVs. So if you were standing here, you could see through that right there. So the wall, it would start drawing the wall from about here, and before that it would just be see-through. So that was just changing the projection matrix, the view start from, it was at 1 and I've set it to 0.1 times the FOV or something, because what happens is, and you can still notice it here on so I had it originally at 0.0001 F, and that you could see black lines through every single model. Well, not through, but around the edges. So this map would look like all the green, but there was the tiles. It looked like green tiles, and it still is happening over there. That's because I'm using 0.1 times the FOV. But yeah, that's kind of a compromise. See, if I change the FOV, it's less, well, kind of less noticeable. Or that shouldn't be noticeable really. So yeah, that's kind of, yeah, a compromise for that one. So I went through that prefab wrapper. So yeah, as well with the prefabs, I've done it for single model render objects to clean up the code a bit. Yeah, and I've also thinned out the player collision box so you can get closer to objects. And I went through that. And that one, fixed that one, yes. Went through that. And yeah, so that's what I've gone through everything I've done this week. So I'll go through the collision in the code. So let's have a look. I'll just turn debug mode back off. I'm going to probably add that to the options menu when that can be bothered. But I'll show you actually first. So instead of having all those lists of different models, I've just put it in the one list of all models. So all models get added to this list, and then that list gets broken up into what gets drawn and not, and also what's interactable and not. So yeah, you can see here all models now. So when I call this prefab add prefab, so this is all new prefab class. So add prefab here, we have the singular models, add prefab, and then down here is the multi-model. So with, say for example with that house, what I've done, I call prefab house, and I pass in a prefab type instead of a object type. So object, if I pass in an object type, I know the code knows that it's going to be just a single model. If I pass in the prefab type, it's going to construct the prefab. So as well, at the moment, it's only correct positioning on if the rotation is at 0, but that will change also obviously as I add more to the prefab. If you change rotation, obviously the position changes of all walls are going to change as well. So like say for example we have the start position, which is the one you pass in as the wall, and then the current position updates on the x-axis. So it goes, so for MonoGame, it starts, x0 is the leftmost point in the map, and then as x continues it moves to the left. So this is, so the start position, let's say, is 0, 0, and then it draws this wall, or it adds that wall, and then it increments the x by the width of the stone wall. But let's say this rotation was 90 degrees. It's obviously, you don't want to increment the x by the dimensions by the width. You need to increment the z by the width, because it's now moving at a 90 degree. So all that will need to be updated and changed based on the rotation as well, which will be coming up later on as I work more on these prefabs anyway. But so yeah, with the prefab we have, it's kind of a wrapper, but it just cleans up the code a bit, so I'm not always calling all models add and grid add, and then don't have to write all this, and you just add prefab and type the object type. So it's kind of limiting it a bit, but I can just make more object types to pass in anyway. So you pass in the object type, you pass in a position and a rotation. So like this one, different position They're all at 0 rotation. Where's one that I put rotation? I think this one. So here, putting the ramp slippery. There's the position. Plus, yeah, that's. So this one I'm just adding next to the ramp sticky. And then here, this is the rotation here. So I'm adding a rotation directly. So yeah, a lot cleaner, except for this interactable. Set interactable, that's not in the prefab at the moment. So yeah, interactables models as well. Doesn't add to. Which I thought it did, because I'm adding interactable models here, but I'm not doing it for. Oh yeah, no. Set interactable, and then here I've got set interactable, but I'm doing interactable models. So hang on, let's have a look. Prefab, add prefab. Door wood. Yeah, I am adding it. Yeah, I'm adding it. So I've just got that extra line that's not needed. Where is it? Here. So this isn't needed because that's now in the add prefab door wood. Door wood. Interactable models dot add. So let's say, so at the moment I'm calling in this once add prefab. Where is it? Let's find it. House. Prefab type dot house. So as you see here, I'm creating it once at 90, 100. But let's say we want to add another one at 190, maybe not so close to the other one. Let's say 300. So with that one line now, I'll just leave it on desktop, even though it's choppy. So there's the original one, and then there's the new one. So you see, with one line, it adds all those objects. So yeah, at the moment the prefab is pretty basic, just a door and 5 walls. But yeah, that can obviously will be fixed. And that's the other thing. If you're gliding this wall when the door is open, you can just pass through it. Which is why collision takes so long, because there's so many different things to consider. So as well, this glide works when you're standing above it. It's just fine. But yeah, there's still a few things with collision that I have to add, and so on and so on. So yeah, that's now the prefabs and the wrapper for creating objects in the world. So it's a lot cleaner on the level objects section. Translations still occur here, but yeah, that's that. Now with collision, where are we? Collision, yeah. So I've added model collision, and at the moment I've just got it in the method itself, just all the functionality, unlike the player. See, I've just got the update, it calls the update position, update translation methods, but here I've just got it. So if the model it's colliding with is not of type falling, so of any other object, if it's colliding with it, and then we do if it's rotatable or not, whether it's AABB or OBB. So So like this one would be if it collides with the floor, or this one if it's colliding with the ramp. So that this model 2 would be the small cube model. Model 1 would be the floor. So here, if it collided, we set the floor collision to true. The position y inverts the velocity, so it does. Yeah, that's to make sure it doesn't pass through the floor. So we set the position upward a bit once, and then the acceleration to 0, and velocity is a value you pass in. So here I've got model bounce height. So when I am creating the objects themselves, I'm setting their bounce heights. So where are they? Here. So I'm making 45. We're starting at 0.5 bounce height, and then we're subtracting 0.001 each time. So 45 objects. So we're adding these. So if we have that on its own, bounce height is 0, so it doesn't bounce, it just falls. So if I show this quickly and can look to the left, it just went through it as well, which is not good. It shouldn't go through it. It's probably because the FPS is so low because of the desktop mode. But yeah, if you saw that before it fell through the floor, they just fall and stay on the ground. But if I add this bounce height, then it'll just keep bouncing. So that's two different functionality that the game can have. That I'm not even sure where I'll use bouncing objects or whatever, but yeah, that's one thing. So that's the. So I've added a few new things. Bounce height here. I've added the velocity acceleration as well. I think that was all I've added to the models. And then yeah, this, if it's falling. So if there's no collision, then so this is exactly the same as gravity, as the gravity G-force. I just didn't want to pass in gravity again, just for that one value. It's kind of pointless even to have the gravity class at the moment, but I might do more with it, so I'll just leave it in. So that's setting acceleration, and then velocity we're just updating with delta time as well, so that it's not frame dependent, and then we're moving it based on that velocity change to delta time as well. So delta time on the velocity and the delta time. So delta time on acceleration to velocity and delta time on velocity to position as well. Don't need it. Actually, I may as well just leave them in both. So that's now the collision type falling functionality. So yeah, with the collision types at the moment, I've just got a few. So floor, platform, roof, wall, door, sticky, slippery, rotation, which is what those constant spinning platforms are, and folding. So that's the collision on model to model. I made changes to a lot of this stuff. I can't remember from last video the changes I've made, but I know for sure with floor, platform and ramp I've done a bit of a difference. So here I'm just getting now the top plane, creating, so this I have in floor as well as the ramp. I've just got it in floor just cause why not. So this is that MX plus C to get the what do you call it, rise over run. So here's the rise over run, and then the rise over run. So P3 minus P1 Y, and then the Z axis. So I'm only doing it, I think, on the Z for the floor, and then C is the height, initial height you set. X is the position that you want to be, I think, no, MZ minus P1Z. Why am I doing Z? Ah, yeah, so, yeah, I'm doing the, so in this case, X is the Z position you want to be. So it's your current position Z minus the Z of the plane, and that's your X. So here, calc Y, MX plus C. So yeah, what you're wanting to do, what I'm wanting to do with this is find the Y. So find your cam position Y, your height on the map that you should be at when you're colliding with the floor or the platform. Well, platform doesn't have that, I don't think, but with that, the floor or the ramp, and then it just sets that. So here, so there's your MX plus C, which is your calc Y, and then I'm saying if your position minus your half dimension Y, if that's less than the calc Y, which is the position on the floor or the ramp at your Z position in this case, then we're setting your Y to that, and then your cam target just gets incremented by that change, which is your current position minus your old, and that's the change in position you just had. So as well, in ramp, I think I'm doing it for both the X and the Z. So here you see the MX plus C. So here is on the Z axis, and here on the X. Even though, so yeah, if we have a rotation on the X axis, then it's the Z. So the height changes along the Z. So kind of like, I'll just show you that ramp. So this one here, the height is changing along the Z axis. So when Z is like, Z is say 1 here, and we're moving up along the Z, and the Y is changing. And this has an X axis rotation. So if the rotation X is greater than 0, or I should really say if it's not equal to 0, because that's what I've done with another section. So I don't have any for both at the moment on the sticky, but I have that on the slippery. So yeah, if there's a rotation X, it's the height is changing as you move along the Z. So we calculate for the Z here, and then that same MX plus C to calculate the I forget what it's called, but the incline or decline or whatever of that plane. And this is the incline and decline along the Z axis, and then we update that Y. So this one here is along the X axis, and then we update our Y based on that. So as you can see, it's two separate. So if the rotation is X or Z, we calculate the Y based on that. But what happens if there's both, right? Then the height wouldn't be, and it's not as simple as adding the final. So it's not as simple as adding whatever this calculates your Y to this one. It works differently. So here I've done all that functionality a bit differently. So for slippery, if we have a rotation on two axes, then we just get whatever the max. So we get those 4 coordinates of the upper plane of the model. So in this case is the OBB, obviously, because all models that have any rotation get converted to an OBB collision box. So we just get the OBB top 4 coordinates. So for that plane, that's, if I bring that up, it's better to just show and then try and explain it poorly. So for this one, we get these 4 coordinates on this upper plane. We get that top. So this one, this one, this one, and this one on this upper plane, not the lower. So with those 4 coordinates, so obviously for that one, rotation X and Z is not equal to 0. So then we get whatever's the highest value. So whatever has the highest height. So for this one, let's say it was P1, and we say if this max equals to P1, then Vx, the vector Vx is P1 minus P2, which means, so P1 here is the upper plane top left, and P2 is upper plane top right. So P1 minus P2 is the vector from top left to top right. So that's let's say that's X, which is kind of what it's not really X, but let's say for the sake of explanation, it's along the x-axis, the change in the vector, and then P1 minus P3 is top left to bottom left. So that is the vector along the z-axis of the model. So we have Vx and Vz now, and what we do is we calculate the result vector, which the result vector is, instead of calculating this rise over run and incline and decline of the plane, so this is kind of like 2D calculations, we need to actually get a vector that is the plane's incline and decline in 3 dimensions on the x and z axes there. So like, I should have just loaded. Let's say this one here. So this result vector is, so Vx, let's say first, is, if we look at it from here, the Vx was, let's say that's P1, right? Then it's P1 minus P2. That's Vx there. So this vector is the distance between those two, let's say. So this vector would be from that point to that point, the coordinate difference, and then Vz would be from this point to this point. So we have this vector, just imagine from here we're drawing an arrow downward to there. So vectors kind of in MonoGame as well are just pretty much coordinates, but I'm using them like a vector, probably the best in these examples, because the result vector will be 3 values, the x, y, z values of the difference between these 2 points. And I mean, in MonoGame anyway, you can apply vector cross products and that, so they're kind of, I guess they are real vectors. They just don't have the what do you call it, the power, the starts with M, I think, the magnitude, that's right. So you don't really set the magnitude, but you can set the you can normalize the vector, and that sets it to 1 if it was a vector of unit 1. There actually might be magnitude setting, but anyway. So yeah, this vector is that, and then we have another vector from here to here, and then what we do is we just add them together, so Vx plus Vz, and we invert. So what that's saying is, by inverting, I think without the inversion it goes like this. So it starts from this point and it goes upward to that. So it goes upward along exactly the same along this plane. And I think it's because this is actually P1 here. So it goes like P1, P2, P3, P4. So it's always pointing. So let's say on this flat plane, it's always pointing like this, like in that direction. Anyway, so by inverting, it's saying from here downward. So this result vector is the exact same. It's the exact same incline and decline in three dimensions as this plane here, or this model. So that's the result vector. And then we're just translating the camera. So translate is just a wrapper for both the cam position and cam target change there. So we just translate by that result vector by delta time, so it's not frame rate dependent. And then I'm doing the exact same if it's singular. So I can do this exact same functionality for this to calculate the X and Z, but this one I have a translate as well. So this one, it would just set your Y for the sticky. It would just set your Y height, where this one would push you in a direction based on the result vector, which is the plane of the model. So is that incline and decline on the X and Z axes. So I don't think I made changes to this, but I have multi-wall collision now. So what I've done with that is player now has, and that's what you saw on screen when the debug mode was on, I have now a list of models that it's currently colliding with, and then with that list, firstly we get, if this count is greater than 1, then we know we're colliding with more than one object. So that might be, at the moment this count only represents doors and walls. So if we're colliding with two or more walls, or a wall and a door or something, then this count will be greater than 1. So this count only gets incremented when we're colliding with one of a walls or a door. So let's say we're colliding with the floor and a wall, this count will still only be 1. But if we're colliding with a wall and a door, then this count will be 2. If we're colliding with 2 walls, it'll be 2. If we're colliding with 2 walls and a door, it'll be 3. And you get the point. So if we're colliding with 2 walls, then we are creating a new bounding box which has this multi-collide vector in it, and this multi-collide vector gets calculated when. So this is all added as well. So this has changed a bit. This handle vertical. So if we're not already colliding with the wall, then we just translate the camera. But let's say we're already colliding with a wall, and we do a. So this is in the condition that we're colliding with two walls. We obviously, it's going to be running this twice, one for the first wall, one for the second wall. So for the first wall, it'll do this. On the second wall, it'll say, alright, we're already colliding with a wall. So what we do is we add this vector instead to the multi-collide vector. So to first wall, let's say we're moving x3, then we just translate. And then because we're already moving x3 because of the collision with the first wall, we don't want to do it again. We want to add it to a multi-collide, which we then calculate against this here, the multi-wall collision, which I'll go through in a bit. But that gets added to the multi-collide vector. So let's say that you're colliding with three objects. The first will translate, the second two will add to that multi-collide vector. And then what we do down here, we create a bounding box with that new position, which contains the change in position from the multi-collide vector. So this might be, your current position plus 3x, 300 vector, and then minus your half dimensions for your min and plus your half dimension for your max. And then what we do is, where are we using that? I've removed that. We're not even using that anymore. I don't think I need it, probably because it was wrong. As I was explaining it, I realized, yeah, I'm not even using that anymore. But that was the initial plan with that. We can remove that. So let's just ignore all that. Multi-collide vector though, I think I am using somewhere? No. Anyway, that's initially how I went about it. And I thought what I was still doing, but Anyway, so what I've done now is we have these two balls, final slide X and final slide Z. So that's what I was explaining before. The models either allow on the X or Z. So let's say we're colliding with those two walls that both have B allow slide X. Then the B, in this case I'm saying if one of them doesn't, then final, you're not allowed to slide on the X. But let's say here, if I find all references here, I'm saying, so this again needs to change based on the rotation, but at the moment for 0 rotation, we're saying that first wall, we're allowing you to slide on the x-axis. Same with the door, same with this wall, well these three walls, but this one that goes, it's been rotated 90 degrees, we're allowing you to slide on the z-axis. So here we're saying, we're first setting it to true, we're allowed to slide on the x and z axes. If any of the objects that you're colliding with don't allow you to slide on the X or Z, then we're setting that final slide to false. And then for the is colliding with, for any object you're colliding with, we're then checking if the final slide is allowed. So if both are allowed, then result movement is just X and Z. Here, result movement is just the Z. Here, result movement is just the X. And this here is just if it's rotatable. So if it's a OBB you're colliding with, or if it's a AABB you're colliding with, it's just the exact same. Remove vector X. Do we even need? I like going through it because then I can see things that aren't really necessary. I think it's exactly the same. Let's see some. Yeah, it's exactly the same. We don't need that. So just that is all. And then this min, this max, I wasn't using at all. So it's just that. And then we just translate based on that result. I'll just make sure I didn't break anything. It looked like it was all the same. Single models are alright. These ones, see, you get stuck on this one. That's because it's that constant. This is a active rotation. There's a door. It's fine. Ramp. Collision is fine. And yeah. So that was just extra code that wasn't needed. And that's another thing, you sometimes can get stuck inside the edge of the wall, but it's another thing I have to fix anyway. I've got a whole bunch of things I have to still adjust with the collision, like going through this door. I mean, that's just fairly minor. As well, when you're on top of the door, the jump is a bit too weak at the moment, but when you're on top of the door, you can, so say you're there, you can kind of slide through this wall a little bit up until your collision box no longer collides with this wall. Then you just stop, and then you can slide like to this position as well. So there's another. And yeah, I shrunk those doors, I think I already said. But yeah, I just resized a lot of objects to be more fitting. So yeah, that looks all correct. Just thinking what else. Let's see in patch notes if there was anything else I had to explain. The B can jump, that's fairly straightforward. Not much to explain, just if you're in the air for greater than 0.1 of a second, B can jump gets set to false. So if you're colliding with a floor or a ramp, B can jump gets set to true. And then you can jump again. And the gravity for the models I already went through, bouncing went through. So that's everything for this week. So a shorter video, still 53 minutes. I thought it was going to be like a half an hour video because there wasn't much to go through, but I guess I can ramble for a bit. So yeah, that's what I worked on this week. Next week I'll probably keep fleshing out the collision and getting the physics system to a point that's to a standard in line with other 3D games. And then I'll probably work on the fleshing out the prefabs a bit, getting some good house prefabs in, and then start. I was thinking last night, like with the gun system and that, and all that, and what I'm thinking is, so with like, say you go into dungeons and that, you find guns, and those guns are kind of like skeletons, almost skeleton or just frames for the guns, and that has just the basic, like, so say you find a plasma gun that has a rapid fire, that's just its core functionality. It has firing rate of 20 bullets per, not 20 bullets per second, but let's say firing rate of three bullets per second, and it hits at 4 to 8 damage, and that's based on the base type gun it has. And then it has a number of slots in it, so like that might have 4 slots if it's a magic item. And then what you can do is you find gun mods, which are like in Battle Court. You have the guns that you just find the gun, and it has a series of mods on it. But what I'm thinking for this game, being a proper ARPG, you'll find the gun itself, and that'll have a number of slots on it, and then in those slots you can put whatever mods you want, and then the mods will also be drops that you find. So like, let's say you find a mod plus 1 damage, or plus 1.1, whatever the damage is, and that's just a normal mod, and then you can attach that mod to the gun, and it gets locked in. You can't change that mod after that. So, that's one mod. And then you might find an awesome mod that you want to put on this gun, like increase firing rate by 100%. So you put that on in the second slot, and then so you can craft your own guns pretty much. And that adds a lot of. Actually, I might not have them attached to the gun permanently. I might just have it so you can pick and choose how you craft the guns. But yeah, balance wise, I'll figure out how I'm going to go about that. But and then those mods might give bullet effects, or might change how the bullet works, or whatever, and that'll add a lot of crafting and creative gameplay to the guns, instead of just finding one gun and that has a series of mods on it, like other ARPGs. It'll be, you craft however you want, you craft your items, and then maybe even for the armors. But yeah, that's kind of what I've been thinking about, how to do the guns and armors and that, because that would be really cool to actually make your own items. You find your base armor, even, you found this awesome armor, and you've got a bunch of mods that you've been saving up that you want to put on the armor, and then you just combine them all, and then boom, nice awesome set of armor that'll get you through, whatever. So yeah, that's kind of what I've been thinking about how to go about it. But yeah, there's still a long way away before I start working on that system. I want to really get even environments out nice, starting to look alright, and get a lot of decent models in the game before even figuring out all that anyway. So yeah, that's kind of what I've been thinking about. So yeah guys, that's it for this video. Thanks for watching, and I'll see you in the next video. Where's my mouse?